Guys, this is section 8.2 in your planner, in your student journal. We're looking at page 223. So what we're looking at today is a specific kind of sequence. Yesterday, the sequences we looked at, they could be anything. They could have been arithmetic, they could have been geometric, they could have been where we're actually squaring each one of the individual terms. So we had a lot of different types of sequences yesterday. Today we're narrowing it down to just arithmetic. So the first warm-up we had, this -1, 6, 13, 20, ... that's an arithmetic sequence. The reason why is because I'm adding on the same amount every time. D is going to be the subtraction of the second minus the first. So D is going to be a sub 2 minus a sub 1. Or D could be a sub 3 minus a sub 2, or a sub 3 minus a sub 2, etc. Or a sub 4 rather, minus a sub 3. So I could say D is always going to be a sub n minus a sub n minus 1. What that means is it's any term minus the term in front of it. D is an important thing to be able to find. Okay? If we're trying to find the nth term and we want to come up with a formula for it, if we know a sub 1 and if we know D, we can quickly come up with the formula for it. Down here they show us an example. The first term is 3, and we have a common difference of 5. So that means we're adding on 5 every time. Or 2, I mean, sorry. I was writing the number 5. So they tell us the first term is 3, and we're adding on 2. So the formula, if we just sub it all in, a sub n is going to be a sub 1, which is 3, plus n minus 2, and D is 2. And when I simplify this, I've got a sub n equals 3 plus n minus 1 times 2. So a sub n is 3 plus 2n minus 2, which ends up being this. All right, for our problem now, let's use the formula. When we did it in the warm-ups, we just figured it out without knowing this formula, but now we can use the formula. So a sub n is going to be, what's a sub 1? -1 plus n minus 1, and then what's D? 7. So now to figure this out, it's going to be a sub n equals -1 plus 7n minus 7, which is a sub n equals 7n minus 8. Isn't that the same answer we got earlier when we did it without using that method? Okay, so this is just a formula that we can use to help us come up with that rule, or that general term is another name for it. All right, now we have a formula. This is for a finite arithmetic sequence. They tell us the formula is n times a sub 1 plus a sub n divided by 2. I prefer to think of it this way, n over 2 times a sub 1 plus a sub n. Let me show you the reason why. Let's say we have this example. Let's say we're adding these numbers. 2 plus 5 plus 8 plus 11 plus 14 plus 17. We're adding those numbers. If I wanted to use this formula, I could, but watch how much easier it is just to do this. What do these two numbers add up to be? What do these two numbers add up to be? And these two. So we end up getting 19 times what? 3. Can you see how that's the same thing as this formula? It's saying add the first one and the last one, and then however many terms you have, 1, 2, 3, 4, 5, 6, divided by 2. See, I don't have to memorize this formula if I understand that method that Gauss used. This is what Gauss used. It was this formula. Okay? He just didn't need to call it by the formula because he just understood the way the pattern worked. So we add up the first one and the last one, however many terms there are, we divide it by 2. All right, let's go over and do some examples now. So in these examples, it says to tell whether the sequence is arithmetic. In order for it to be arithmetic, we have to always have the same d value. What's the d value here on the first two terms? Next to? Is the next two, would it be 3? No. So right away we know no. D changes. All right, what about on this one? What's D? -3 always, right? So we can see, yes, that is going to be arithmetic. All right, what about here? Do we have the same D value? Yeah. What about this one? Is 1/4 minus 1/2 the same as 1/6 minus 1/4? The same as, those are not going to be the same, are they? And this is tricky for people because they're like, yeah, but you're adding 2 to the bottom every time. Yeah, but we're not having the same D value. 1/4 minus 1/2 is not the same as 1/6 minus 1/4. Therefore, no, it's not arithmetic. That doesn't mean that I can't come up with a rule for it. The rule for it would be what? 1 over 2n, right? 1 over 2n. So I can come up with a rule, it's just that it's not an arithmetic rule. All right. Write a rule for the nth term of the sequence, then find a sub 20. Guys, you can do this any way you want. If you want to use our new formula, you can, but a lot of you can probably do this without our new formula even faster. Can anyone tell me what it would be using the method I showed you before? Right? You got it. Right? We don't have to use a formula. The change is always 6. So the D value or the change in those numbers goes in front of the n as the coefficient. Then I have to think, what do I have to do to 6 to get 3? Subtract 3. Okay? Here's the other way I could have done it. I could have said a sub n has to equal a sub 1, which is 3, plus n minus 1. My D value is 6. So I would have 3 plus 6n minus 6. And so that's going to give me 6n minus 3. See how I get the same answer? Either way you want to do it. We have to now find a sub 20. So that's going to be 6 times 20 minus 3, 117. Okay, you guys try number 6 now and raise your hand when you know it, because I want to see how quick you can do it. Got 1, 2. You can put your hand down once I say you. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so a lot of people have it. All right, so Morgan, tell me how you did it.
So I found D was -5, and then a sub n equals -5n. And then to get 8, you would have to add 13 plus 13.
Good.
And when you substitute 20, I got it.
Close. I think you're going to get -87, right? Yeah, good. Nice job. So I think it's quicker to do it that way than it is to use our new formula, isn't it? Okay, but sometimes it's going to get more tricky, and in those cases we may want to use the formula. Let's go ahead and do this one together with the formula, all right? When we have fractions, decimals, I don't know, it might be easier the other way, but we're just going to practice the formula. So we're going to do a sub n equals a sub 1 plus n minus 1. What's D going to be here? It's a half, isn't it? So now I'm going to have -1 plus 1/2 n minus 1/2. So it's going to be 1/2 n minus 3/2. So a sub 20 then, half of 20 is 10 minus 1.5. That's going to be 8.5. Let's do this one the old way. A sub n equals, what's our d? Right, so negative 0.5 n. Okay, now what do I have to do? Negative 0.5 times 1 is negative 0.5. What would I have to do to get 0.7? Plus 1.2, good. So now a sub 20 is negative 0.5 times 20 plus 1.2. That's negative 10 plus 1.2, negative 8.8. Okay? So just understanding those two formulas. All right, now we're going to look at some problems where we have to use the formula. There won't be any other option. Okay, if your book ever tells you to graph on these, you don't have to graph. I don't think it's necessary. So this one says, write a rule for the nth term of the sequence where a sub 12 equals negative 13 and d is negative 2. See, they're not telling us the pattern, and they're not telling us the first term. So we're going to have to use the formula. So I'm going to write my formula. A sub n equals a sub 1 plus n minus 1 times d. They give me a nice piece of information here. They're telling me when n equals 12. When n equals 12. What is a sub 12? What's the answer to a sub 12? So I would plug in negative 13 for a sub 12. Do I know a sub 1? No, so I have to just write a sub 1 plus, do we know n? It's 12, isn't it? So 12 minus 1, and do we know d? Yep, negative 2. So now, can you see how I'm going to be able to solve for a sub 1? So I'm going to do that. So negative 13 equals a sub 1 plus 11 times negative 2 is going to be negative 22. So now I'm going to have to add 22. So I'm going to get 9 for a sub 1. So now I have some options. Now I know what the first term is. And I know the pattern too. The pattern is going to go 9, minus 2 is 7, minus 2, minus 2. There's my pattern. So now you can either use the formula, or I bet most of you could figure this out without using the formula now, right?
Yeah.
So it's a sub n equals, what is it? 2n, and then
Minus 1.
I got to get a 9
Plus.
plus 7. Or I could just go back and use the formula if we wanted to. Okay? But either way, that's going to be it. And then they want us to find the first 6 terms. Well, I already found the first 4, 5, 6. There we go. Okay. Getting a little bit more difficult. All right, look at this. They're telling us the 8th term is 59 and the 13th term is 99. How am I going to find anything out with that piece of information?
Well, if they're like 5 terms apart, the difference is 40, if you divide 40 by 5.
You're right. Here's how we do these, guys. We would do 99 minus 59 divided by how far apart are the terms. Well, the terms are going to be 13 minus 8 apart. It's really like we're finding slope. It's like we're doing y2 minus y1 over x2 minus x1. It's just slope, really. So we're going to have 40 over 5. And what does that represent? Which is d, right? So now we know d. Once we know d, we should be able to go ahead and find out what a sub 1 is. Here's how. I'm going to say when n equals 8, just like I did the last problem. I know my formula. A sub n equals a sub 1 plus n minus 1 times d. So when n equals 8, what is a sub 8? see, 59. So 59 is going to have to equal a sub 1. Do I know it? No. What's n? So 8 minus 1 is 7. Do we know d? 8. So now we've got 59 equals a sub 1 plus 56. So a sub 1 is going to be 3, right? So now you have options. Now you can go back and use the formula again, or I just like to write out the sequence. 3, 11, plus 8, 19, etc. So now could you write the formula? It's a sub n equals what? Can everybody do that? Understand where we got that from? Or you could go back and use this formula and plug in for everything that's necessary. Plug in here, and then distribute. I'm going to do that one the other way, okay? All right, so first of all, I need to find out what d is. D is going to be negative 8 minus negative 5 over 27 minus 18. That's going to give me negative 3 over 9. So that's negative 1/3. So now I've got D. So now I can choose either one of these two. Doesn't matter. Let's go with this one this time. So when n equals 27, here's what I'm going to be using, this formula. A sub 27 is negative 8 equals a sub 1, I don't know, plus n is 27. 27 minus 1 is 26. D is negative 1/3. So I'm going to have negative 8 equals a sub 1 minus 26/3. I'm going to have to add 26/3. Well, I know this would be negative 24/3. Everybody with me here? I'm just rewriting negative 8 as negative 24/3 so I can add. So then 2/3 is going to be a sub 1. Okay, now I told you I'm going to do this one the other way. So now to come up with my formula, I'm going back. I'm doing a sub n equals a sub 1 plus n minus 1 times d. Now I'm going to substitute in here and here so I can come up with the formula. So a sub n for any n is going to be a sub 1 plus n minus 1. My d is negative 1/3. So 2/3 minus 1/3 n plus 1/3, negative 1/3 plus, negative 1/3 n, sorry, I forgot that, plus 1. Yep, that's it. That's kind of tough, isn't it? It's just because of the fractions. And it's also tougher because I chose to use this larger one. It's always easier to stick with the smaller numbers instead of the larger ones. All right, any questions on that? All right, let me show you a quick way you can do this without even using your calculator. All right, so we're going from 1 to 22. How many terms do we have? 22 terms, right? So remember how Gauss did this? He did 22. What did he do to the 22? Divided it by 2, right? And then what did he add when he was adding from 1 to 100? The first number and the last number. So I plug in 1 to get the first number. 5 minus 2 is 3. Now plug in 22. 5 minus 44 is negative 39. So I just have to do 11 times negative 36. And I still have to use a calculator. I don't really have to. 10 times negative 36 is going to be 360, and then I'd have another 36. 396. Okay, so it's negative 396. All right? Okay, good stuff there. So make sure you know those formulas. Like I said, I suggest understanding them instead of memorizing them. This one, you are going to have to know to do those more difficult problems. The sum one right here, this one, I told you, like, it's easy just to think of what did Gauss do. Those of you who were absent didn't see that lesson about how he added up the numbers from 1 to 100, but he just did 100 divided by 2 and then 1 plus 100 to get that sum. So